Hello everyone, welcome back to chemistry class. In today's video, we are talking about thermal methods, a technique that help us understand how material behave when they are heated or cooled. In today's video, we are dealing with introduction to thermal methods, type of thermal methods. In this, we'll all cover thermogravimetric analysis, differential thermal analysis, and differential scanning calorimeter. Let us start with the introduction to thermal methods. Thermal analysis is a branch of material science where the properties of materials are studied as they change with temperature. Thermal analysis is defined as a group of methods by which the physical or chemical properties of a substance, a mixture and/or a reactant are measured as a function of temperature or time. The sample is subjected to a controlled temperature program. The program may involve heating or cooling, that is dynamic process, or holding the temperature constant, isothermal process, or any sequences of these. These techniques are extremely valuable in understanding the thermal stability, composition, and behavior of material. Thermal methods are widely applied in chemistry, material science, pharmaceuticals, polymer industry, food industry, metallurgy, and many more. Let us now see basic principle involved in thermal methods. A sample is heated in a controlled environment, that is air, inert gas, vacuum, etc. As the temperature increases, different changes may occur such as mass changes. This is due to decomposition, oxidation, or evaporation. Energy changes, endothermic or exothermic processes. Change in dimensions or physical properties is due to expansion, softening, and crystallization. These changes are recorded as curve or also known as thermograms, which provide information about the thermal characteristics of the material. This helps scientists study decomposition, melting point, phase transition, and chemical stability. The three most commonly used methods are thermogravimetric analysis, differential thermal analysis, and differential scanning calorimetry. Let us focus now thermogravimetric analysis. It measures change in mass with time. It is useful for studying decomposition, oxidation, and moisture content. TGA consists of following apparatus in their instruments: furnace, sample holder, sensitive analytical balance, unit for measurement and control of temperature, atmosphere control, and recorder. And a typical TGA instrument look like this. So till now we have covered introduction to thermogravimetric analysis. Now we have to focus on introduction to differential thermal analysis. It measures the temperature difference between sample and reference material, detects endothermic and exothermic transitions, that is melting, crystallization, etc. A typical DTA instrument consists of sample holder, suitable thermocouples, furnace with temperature programmer, differential detector, recorder, and atmosphere and coolant control. You can clearly see the arrangement of all the instrument in the above diagram of DTA. Till now we have covered introduction to TGA and DTA. Now let us focus on introduction to differential scanning calorimetry. DSC is quite similar to DTA, but instead of just recording the temperature difference, DSC measures the heat flow directly. It provides quantitative data about enthalpy changes, melting point, glass transition, and reaction kinetics. A typical DSC instrument consists of sample holder, suitable thermocouples, furnace with temperature programmer, heat flux detector, recorder, and atmosphere and coolant control. All the part of DSC you can see on your screen. And That's the introduction to thermal methods and its types. Thank you for watching. Comment below if you'd like me to explain more topic like this.